All right, next on our list is, so that was 12 that we just did?
Yes.
Okay, so let's get 15 now. 15 this is like, totally like, this could be an AP physics, like an AP test question. It hits a lot of things. It's got simple harmonic motion, it's got conservation of momentum, it's got energy, it's got projectiles. So this hits a lot of chapters, all right? So this is a really, really good problem, all right? So let's take a minute and run through it. Okay, so here we go. The figure at the right shows a block. Oh, so what are we doing here? This is number 15, right? So 15.1, number 15. So, so here's block 1, here's block 2. It's attached to a spring with a constant K. Here's what we know. We know that the mass of block 1 is 0.2 kilograms. We know that it is sliding to the right over a frictionless elevated surface at a speed of 8 meters a second. So the velocity of 1 initially is 8 meters a second. It's moving this way, so let's call that a positive direction, yes? Okay, the direction will be important here. All right. Okay, what else do we know? The block undergoes an elastic collision. Super important, okay? It's an elastic collision. So remember, this is a thing that will be a good review for the test itself. In an elastic collision, two things are true. One, total momentum is conserved. That's true in any collision, right? All right, and then do you guys remember we learned a super secret ninja shortcut that you can use? There was something that was true in any elastic collision. You guys remember what it was? Something to do with, so I guess, what's the definition of elastic collision? That's completely inelastic where they stick. So this is the other end of the spectrum. We got energy. Energy is conserved. So that means we have to have just as much kinetic energy before the collision as we do after. Okay? So one way to solve it is to set up a system of equations. One for momentum, one for kinetic energy. But I showed you guys that you could replace the kinetic energy equation with the sum of the velocities is the same for both objects. So, and it's weird because it doesn't have any conceptual meaning, but it's this. The velocity of 1 initially plus the velocity of 1 final happens to be equal to the velocity of 2 initial plus the velocity of 2 final. Cool? Yes, sir?
So how were we supposed to pick up if this was an elastic collision?
It says it.
It says it does.
Yeah. Cool. Sorry, that was not meant to sound snarky, but it's easy to like read through this stuff and miss those types of things. So yeah, watch out for that. All right, everybody good up to here? Okay. Let's see. What else does it tell us? It tells us that block 2 is attached to a spring constant, or a spring with a constant of, who wrote this? 1,208.5 newtons per meter. Yeah. All right. It says, assume the spring does not affect the collision. After the collision, block 2 oscillates in simple harmonic motion with a period of 1.4 seconds. 0.14 seconds, sorry. And block 1 slides off the opposite end of the elevated surface, landing a distance d. So the idea is block 1 is going to go boom, and then bounce back and go shooting off. It lands a distance d away, where d is what we're trying to find. We know this height here is 4.9 meters. Okay. Half of 9.8, which is significant, and hopefully you guys know why. If not, we'll talk about it here in a second. All right. So I think we've got all of our givens written down. So yeah, go ahead, Tama.
It hits 2. 2 does the oscillation, and it hits 1 again. What's
I don't know what 1 does after the collision. We need to figure that out. Because it's an elastic collision, my guess is that it's going to bounce back, but I don't know for sure. Follow?
Yep.
Okay. So to me that feels like maybe a good place to start, right? Is to start with that collision. All right? So in order to do that, let's see, what else do we know? We know one other velocity. We know that the velocity of 2 initially is 0, right? Okay, but the problem is I don't know either v1f or v2f, right? So right now this equation here is this. 8 plus v1f equals 0 plus v2f, right? Okay, and my goal is, in order to figure out d, in order to figure out how far my projectile goes over here, I need to know v1f, right? My hope is that it's negative, otherwise the question doesn't even make sense, right? Follow?
Yeah.
Okay, so there's something, okay, so we know it's an elastic collision. We know it's a collision, so this tells us that our momentum has to be conserved, right? So that means that the mass of 1 times the velocity of 1 plus the mass of 2 times the velocity of 2 has got to stay constant, right? But there's a problem there. How many unknowns are going to be in that equation, you guys? I don't know either of my 2 final velocities. There's one other thing I don't know. We don't know the mass of block 2. All right, so I'm kind of stuck here because too many unknowns. So, all right, so I wonder, we haven't used any of this garbage yet. That feels like it might be important. Doesn't this depend on the mass and k? Right? Remember, you guys, the period of a simple oscillator, a simple harmonic motion, period is 2 pi times the square root of m over k, right? Oh, and I know my period and I know k, so I can find the mass, right? Do you guys understand that that's mass number 2? Because that's the object that's going to be in simple harmonic motion, right? So if you solve that, mass 2 ends up being, I have it written down, what number is this? This is 15, which on my thing corresponds to 22, which means that mass 2 is 0.6 kilograms. Cool? Any problems? So, okay, so now I think we can solve this thing. So let's use this garbage here and write an equation. So the mass of 1 times the velocity of 1 plus the mass of 2 times the velocity of 2, so that's all my initial, right? Has got to equal the mass of 1 times the velocity of 1 final plus the mass of 2 times the velocity of 2 final. Follow? All right, so now I've got a system of equations. Right? We got this guy because it's elastic. We got this guy because it's momentum. So if you replace v2f with 8 plus v1f and plug it in down here, we can solve for v1f. Is it okay if, in the interest of time, I skip over the algebra there? Does everybody see that it's a system of equations? I don't say that like, oh, it's just a system, right? Like, it's complicated, but I think you guys can all slog through that algebra, right? All right, and so if you do that, you end up finding that v1f is written on my paper somewhere, negative 4 meters a second.
Did we know V2F?
No, but we could find it now because I know that v2f is just 8 plus v1f. Do you know what I mean? Because you've got a system of equations. You've got 2 unknowns.
Oh.
So it happens I found this one first, And now that I've found it, I could, if I wanted to, plug it back in and
Yeah.
find the other one.
Okay, yeah.
Is that a genuine okay, yeah, or a?
Yeah.
Okay, everybody good? Okay, so now we've got our V1F, so now we know how fast our projectile is moving when it goes off the edge. What's the one other thing we need to find? The time, right? It's moving horizontally at 4 meters a second for some number of seconds in the air. How long will it take a thing to fall 4.9 meters?
1 second.
Yeah, 1 second. You guys remember that? Because half of 9.8. If you didn't remember it, it's this. Vertical displacement is 1/2 vertical acceleration times time squared plus initial vertical velocity times time. What's our initial vertical velocity, guys? 0. So this goes away. Oh, sorry, I said I wasn't going to use that color anymore. So we got to go down 4.9 meters. 1/2 times negative 9.8 times t squared. Oh, the time is 1. So it looks like it's just 1 times 4, and it went 4 meters. Sorry? It is the square root of 1. Yes. All right, everybody good?
Square root of 1.
Okay. Cool. Too fast? Any problems? Are we good? So about how you feeling?
Great.
Everybody good? Anybody ungood?